let's talk about this, Dipanjan. So just give us an understanding about what can people say, from where did they get the data set, why did they choose this particular project, why did they choose this, how did they work on this, what can be the challenges while working on this particular project. Let's start with from where did you get this particular data set and why did you choose this particular project?
Correct. So IMDb dataset, you can get it from Kaggle, and this was the very first NLP project that I've done. I would say, I mean, you can say like that, that this is the first NLP project wherein you trained a model from scratch to basically identify whether a review is positive or negative or neutral, right? So you can either keep it as a binary or a multi-class classification, but the aim was basically to understand it was a natural language understanding problem here, right? So you have to get a proper embedding such that, I mean, you have to learn from the embeddings whether the sentiment is positive, negative, or neutral, right? Yeah. So, yeah, Ramesh, go ahead.
So, Dipanjan, what can be the ask in an interview, and what was the experience while working on this project basically?
So this is I mean, a project that comes very handy nowadays because a lot of industries will definitely use this. Okay, like even if you are creating a chatbot, the very first thing you do is like whether to, I mean, to identify whether the question is a valid question or not a valid question, right? So let's say that you want to build a chatbot, and in the chatbot there is something like it talks about some domain. Okay, let's say medical domain. Okay, so you ask a question related to some medicines, and it should be able to answer questions on only that particular topic. So if it is a non-medicine related question, or it's a what is it called, some gibberish thing that you're trying to put into the chatbot, okay, or saying what is your mom's name or things like that, right? Which is not a valid question. So you don't want to entertain these kind of questions. So you have to keep a layer on top, right? Like before you basically use the entire flow of the chatbot, what you can do is basically identify whether these questions are valid question or not a valid question. Okay, uh, related to a domain. So in these cases also you're going to use something like this, right? So that is why it is very important, and a lot of interviewers are very interested, and they'll ask a lot of. I mean, if you are applying for an NLP, GenAI role, or any role related to chatbot creation, these questions is like 100% guaranteed that I'm going to tell you now. Okay, so you can be rest assured that. Okay, so questions that can come from here is of course data cleaning, which is the most important thing. Okay, so nowadays you will have like use case based problems, like they'll say that I have a PDF. Okay, now I want to basically clean the PDF in such a way that I can only get uh, the best. I mean, to get a proper tokenized words and vocabulary out of a PDF, right? So, like they'll try to come up with a different use case for you, but moral of the story is this only, right? When you do data cleaning, there are XYZ steps that you can follow, right? Like the one mentioned here, like stop word removal, punctuation removal, then uppercasing, lowercasing, right? Then why do you need uppercasing, lowercasing, right? I don't think I have included the case change, right, of alphabets here, but that is also an important thing to basically standardize thing, right? So DOG capital and DOG small are, if they mean the same thing, why do you want to keep two different things in your vocabulary, right? So you can basically convert the entire thing into a lowercase and then do the tokenization. Okay, before that, what is tokenization is a question. Okay, like yeah, Ramesh, go ahead.
So,
You're saying
can
something.
we add that point here related to tokenization as well?
Yeah, you can add. Wait a minute. Stop word removal, punctuation removal, word removal based on frequency. Before lemmatization, you can add this uh, case standardizing. Case standardizing. It's just a fancy word to basically say that you just lowered each and every letter of the uh, like in your paragraph, right? So if you have a paragraph or a review there, okay, for this particular case you have a review, right? So some people might be, oh, okay, there are few other things as well, like emoji removal here. Okay, so that also you can add. Maybe you can create
But
your
all
own
those things
module
should
there.
be added, or that all comes as a part of data cleaning. Are we supposed to add all
It
those things?
is,
Will that be helpful?
you can just write etc. for now, but like in the interview, you can talk like you did emoji create cleaning, then email ID and PII removal. Okay, like personally identifiable uh, unique IDs, right? So like somebody might have put their mobile number and said, if you like the movie, call me on this number, okay, something like that. So you want to remove those details, right? So those cleanings are also a part of your cleaning, right? So you don't want to feed PII or personally identifiable IDs to the model, right? Otherwise, it will be a biased model. So you don't need to basically enter these into the model, right? So those things also will be a part of your cleaning. You can make your own. So people who have already worked on this, right? They will know what are the different cleaning strategies they have done. Okay, what are the different steps they have taken to clean the reviews, right? So it can not. It's just not limited to these things. There are n number of steps that you'll find online in Kaggle notebooks. Okay, there will be 100 different ways to do cleaning. Okay, but some there are few things that are pretty much seen in almost all the projects, like lemmatization. You're trying to create your own model, right? So okay, what is lemmatizing and stemming? This is an important question. Okay, what is the difference between lemmatizing and stemming? Okay, so you do either one of these two. Either lemmatize your sentences, I mean words, or you do stemming of your words. Okay, so which one did you use and why did you use it? Okay, so lemmatize. There are multiple. I think multiple lemmatizers. Okay, in the market. Just search for it. Okay, there are. I think there is one Lancaster lemmatization or stemming. So there are multiple. Okay, just check. Okay, in the online you will find one is very strict, one is very aggressive, and another one is little less aggressive, and things like that. Porter stemmer and Lancaster stemmer. So they are two stemmers basically that are being used pretty uh, widely nowadays. Okay, I think
Yeah, Dipanjan, can you?
yeah,
Yeah,
now I can unmute.
yeah.
So yeah, so stemming and lemmatizing is one question that you will get. Okay. And after that, how did you define on the cleaning strategy, right? Like, how did you basically confirm that this is the cleaning strategy that I'll be using? So, okay, I think there is a question. Oh, no, there is no question. Okay, fine. So, uh, where is that part? Huh. So, you also did like top 10% and top bottom 10% frequently occurring word removal, right? So, even after you remove stop words, okay, there are few words like movies, okay, like, of course, like when you're talking about movies only in IMDb dataset, that it is pointless to basically keep the word movie, okay, in the review. So whenever I'm talking about something, the movie word or the video or these kind of words may occur a lot, right? But maybe this is not something that is maybe this particular token like movie may not be very important for your model's performance, right? Like movie, does it give you any positive or negative sentiment there? No, right? So probably you can remove these kind of words which are coming a lot, right? Which are occurring a lot. So top 10% or bottom 10% words which are like hardly happening. Like let's say that there might be words like Shah Rukh Khan without space or things like that, right? So very few such words are there which come in the bottom 10% of your total vocabulary's frequency. So you can remove those words. That will basically make your model perform better. Okay. So those steps you can talk about. Okay, so they'll look into these things and they'll ask you that why did you do this? Okay, so you can say these reasons that I just mentioned, right? Like movies and things like that coming uh, often, right? You can remove those things and things like that, right? Then this is about your data cleaning. Okay, multiple data cleaning operations that you have done. And of course, like target profiling is again important for every ML use case, right? You basically try to figure out how many positive and negative and neutral sentiments are there. Okay, profile by the number of, I mean, by the frequency. Okay, so if you have like out of 103, I mean 97 to 3 ratio. Okay, so 97 percent is positive sentiment and 3% is negative sentiment. That means if I am about to train a model with a 97% accuracy, it is useless, right? That means I can blindly say it is a positive review. Without even looking into the review, I can simply say it's a positive review because 97% probability is it is going to be a positive review, right? As per your data set. So if you train a model which is better than 97%, only then it is going to be useful, right? So for that, you need to do the target profiling. So you need to check like already 97% I have, right? I mean, 97% so is a positive and 3% is your negative. So that way you need to do the target profiling and also set your benchmark, right? You need to say that, okay, if I do not train a model and simply say positive for everything, then I'm going to get 97% accuracy anyway, right? I need to have at least 98% performance using my model, right? That is how you have to basically benchmark, right? So that is why your profiling is handy. So they may ask you this question like, why did you do target profiling? What is target profiling? And like, what are you basically trying to do with target profiling, right? So if you find data imbalance, we already talked about this last class, right? If there is an imbalance in the data, what do you do? SMOT, and there are hundreds of ways to basically oversample, undersample, and do a lot of things, right? Do post processing, do pre processing. Multiple steps are there in imbalance data handling, right? So you can talk about those things as well. Okay. So those questions again can come here uh, when it comes to your target profiling and imbalance data set handling, right? Now, now this is very important that how did you train your model, right? So if IMDb data set is pretty huge, right? Let's say there are, let's say 10,000 reviews, okay? So if you want to train a model that has, uh, you're using a TF-IDF with a vocabulary of 40,000. So you have to tell them, okay, so 40,000 into 64 bytes, right? Uh, that much memory is being consumed by each and every embedding, each and every number in your embedding. It's a huge number of memory. It's a huge memory overload there, right? So what you can do is only take a subset of your data for your training, okay? Otherwise your laptop will crash. So these things are very important. So how are you basically training your models, right? Did you basically do some memory footprint reduction, or how did you change the data type of your uh, embeddings, or how did you basically handle such a huge amount of data? So looking at these things now will basically force the interviewer to ask the questions in these areas. Okay, so that way you will be well prepared that okay, dekho, why did you create batches? Okay, why did you create batches for model training and things like that? You can say that I was having issues with my memory. So if I use the entire thing to train our model, then it will be a problem. So because I was getting out of storage, okay, errors, out of memory issues, right? So I had to train it in batches. And also it's a good practice to basically train it in batches, right? Train your models in batches. So that is a very, and also you use NumPy, again, an important thing here. So you can directly feed your data frames, your pandas data frame for training jobs, right? But you did it in NumPy so that again you try to reduce the memory there, right? So these things play a very important role in your interviews. Then, okay, apart from these, okay, this is a very generistic questions. Apart from these, you will have generic questions. I mean, apart from this, you will all get what is TF-IDF. Okay, what is the formula for TF-IDF? Okay, then what is XGBoost? Of course, like this is your algorithms. Coming to the vectorization part, you will have what are the different vectorization tools that you explored, right? So, did you use is TF-IDF contextual? Does it capture the context or not? Okay, so these kind of questions you'll get. Then if I also one important question that I sometimes ask a few people is like, let's say that you have these sentiments, okay, and you did a TF idea. So will cosine similarity decide whether these two particular reviews are closer to each other or not? Okay, so I did a TF idea and I
I
have
think
multiple
yes,
vectors. Okay, so this is a very important question sometimes that you can get. Okay, so just try this thing out and see why it is yes or why it is no, and when yes, when no. Okay, it should not be technically. Okay, check. Okay, because TF-IDF doesn't capture contextual embeddings. Okay, of course, like if you have these things, right? If you have matching words, that way you will have a very close TF-IDF there, right? Because your multiple dimensions are matching, right? Then you will have a very nice cosine similarity. So do you want that? So that is the question. Now, is it similar or not is a different question, but it's an open-ended question, right? You can basically discuss with the interviewer. Ki, uh, why is it similar if similar? Why is it not similar if not similar? Or it can be or may not be, okay, whatever it is. So just think about it. So it is a question like for each and every embedding, you should know all these things, right? Like if you talk about BERT, okay, they are trained in such a way that the similar embeddings uh, should have less cosine distance, right? So that is how BERTs or universal sentence encoders are already trained. So there you don't have any problem. You can blindly say yes, cosine similarity is I can use on BERT and use directly. But for TF-IDF, it's a shaky spot there. Okay, like when or when not to is what you have to be very carefully talking about, right? So this is one thing. Then okay, so these questions, okay, these are probably I would not ask these questions to a fresher, but for a experienced candidate, these questions actually uh, they get confused. Okay, like I have never used with TF-IDF cosine similarity is what I get, but this is a case-based situation, right? If you had to use, then what would you do? But they'll be like confused or they'll not understand what this thing is. They'll not know what is cosine similarity in many places, right? So know about these things. And of course, these algorithms. Okay, algorithms ka to just I don't think if you're preparing for an interview, it would take like 2 to 3 days max to completely prepare all these algorithms, right? Of course, like when you're using BERT and use, you should know what transformers are, transformer architecture, but they will not go into a lot of details. Okay, when they talk about transformers. Okay, so uh, but before these things, you also need to know LSTM and RNNs. Okay, that I think is a part of another this thing, right? Do we have that RNN and LSTM project sequence-based model, Ramesh?
No, text to code generation, right?
Yeah, yeah, text to code.
No, no. It's going to be
Don't have.
chatbot.
Okay. Okay. So before this, then I think you can also learn about the evolution of sequence-based models. Okay. Since you already wrote BERT here, you should know what sequence-based models are. Okay. Okay. Not all interviewers will expect this, but like they will ask questions on terms of what is a sequence model. What do you understand by a sequence model? Okay. Any model that can capture sequence, right? Now, how will you capture sequence? Okay, so you have RNNs, you have LSTMs, you have GRU. Okay, these can capture sequences. Okay, there are bi-LSTMs. Okay, now there is on top of all these things, there is a transformer model. Okay, so what is
May I know,
transformer?
Dipanjan, what is the meaning of sequences?
Correct.
Sequences.
So see now, as of now, you're looking at sentences, right? Like I am a good boy. Let's say, okay, I am a good boy is a sentence, right? Now, if I consider I as a separate word, am as a separate word, and so on, and if I place these I am a good boy anywhere, like a good boy, I am good boy, am I, okay, keep anything anywhere. Okay, is your TF-IDF embedding going to change? Okay, think about it. So actually
Yes,
these,
yes, it may change. It may change.
it will not change.
Okay, it will
Your
not change.
numbers will not change. Just check, okay, it will not change. So uh, it doesn't depend on your sequence, right? Your TF-IDF actually doesn't capture the sequence. It can be anywhere in your sentence. I am a good boy can be in any jumbled fashion, right? So it cannot capture like I ke baad hi am aaya. So I, then am, then a. It is not able to capture that sequence. So there are few models that can capture these sequences. Okay, let's say a video. Okay, how can if you want to fit a if you want to train a model that can basically look at a video and say something about the video, let's say. Okay, so you want to understand sequences of different frames, right? Image frames. So image 1 t is equal to 0, image 2 t is equal to 1, image 3 t is equal to 3, and so on, right? So you have to give multiple images to a model and then it has to decide. So this is again a sequence, correct? Even time series are sequences, right? So let's say that I'm not sure if you're from mechanical or civil. So let's say that there's a room here, okay, and um, there is a room here, and you heat one particular corner of the room, okay. So what will happen with time? The temperature will spread, right? I mean, the entire room will be filled, will get hot slowly, right? So with time, different locations have a different temperature, right? So this is a time series model again. So even your forecasting problems are time series. So you have a sequence there. So today there will be some price, tomorrow there will be some price, day after tomorrow there will be some price, and they are all related, right? So that is how sequences are, and there are few models that can capture these sequences. Okay, so RNN is the very first model that could capture sequences. What it does is like you can, for the first t is equal to 0, you can capture one entire vector, right? So let's say I am a good boy. I का एक vector बनेगा. Am will be another vector. A will be another vector, and so on. Okay. So these kind of models that can capture sequences are called sequence models. That's all. Okay. So BERT इससे
Oh,
एक level ऊपर है. ठीक है. BERT can basically uh, do much more than just capturing sequences. Okay, it can read the entire sentence completely. Okay, read about these things. Okay, read about transformers. Read how is it different from LSTM and RN. Okay, that is a very important question that you will get. Okay, and one very common question here is RNN versus LSTM. Okay, ki RNN में what are the drawbacks of an RNN that are basically covered by an LSTM. Okay, so gradient boosting and sorry, your vanishing gradient problem and exploding gradient problems, right? So those things you can look at. Okay, and other than that, I think transformers, RN and LSTM are good. Okay, to basically get a good idea of how the candidate is, and I think we are good here. Okay, of course, like after you do all these things, okay, itna kuch to kar liya, then you have coming to the evaluation metrics, right? So when you say, now, uh, so you have this final selection, right? Champion model, challenger model. So people may ask you, like, when you're saying champion model and challenger model, okay, is there a way in which you're basically storing these models after training so that you can basically understand, right? Which one is champion model, which one is challenger model? So these things basically happen in version controlling. Okay, so you can say that I know how to use MLflow or something like that. Okay, I know how to use MLflow, but for now everything was happening manually. So I just wrote champion model BERT and challenger model TF-IDF plus use and saved it. Okay, you don't have to go into a lot of detail. Why? The reason why you have champion model and challenger model is because someday the challenger model may become a champion model. Okay, with probably a lot of data coming in, you will have maybe the challenger model become better than the champion model someday, right? So that is the reason you put this in your resume, and then when the interviewer asks, you know what is what. Okay, so this is more about the versioning of your models. So you trained a model today, you trained a model tomorrow, you trained a model day after tomorrow. What happens if suddenly you find out that the latest model is worse than model 1? Okay, this happens. And now what will happen is you'll say, "अरे यार, मैंने तो पुराना model को delete कर दिया." What will happen now? Okay, you have to fall back to the version 1, right, where you had a better model. So that is why you have to maintain these model versioning very well, okay, in your machine or wherever you're storing these models, right? Like in cloud, you have multiple places to store these artifacts and things like that, but versioning is very important. Okay, so that is why these champion challenger models come into picture, okay, for versioning. Then other than these things, of course, like evaluation, accuracy वगैरह जो भी है तुम बोल देना. Okay, then recall, precision, accuracy, these questions definitely come. For a fresher though, this is the very first question that they will come up with. Okay, so what is recall, what is precision, what is F1 score, what is accuracy? These questions will definitely come. Okay, I think we are good with IMDb sentiment analysis.
Okay. So Aditya, so using this information and the information that we discussed earlier, I'm sure that this particular project you can start working on it or in parallel start other stuff as well. Okay. And,
Yes, Ramesh, I will be doing that.
and
And
you already
he has
completed
already told a
a
lot of
project,
things
right?
actually.
Hello.
Yeah,
Hello.
Aditya.
Yeah, Ramesh. Yeah, tell
No,
me.
no. So, okay, chalo, we'll carry on. We'll carry on. So, Aditya, use the input shared now. That would be from interview point of view, but this will
Mhm.
also help you to understand and get the better understanding about the project. That is what I was
Okay.
talking about. And
Talked
yes,
about the vanish gradient problem and gradient boosting problem, then recall, accuracy, precision, F1 score, all these
so
things he told. And
right, and basically how it works
Understand,
is
Greg.
that more and more whatever you have done, you will have to be aware of everything because interviewer will try to ask you as much as you can. So all the related things will have to be understood and it will have to be there in your kitty.
Okay,
Chalo.
it's not gradient boosting, okay? That's a different concept altogether. I was talking about vanishing gradient and exploding gradient. Okay, not boosting gradients. Okay.
ठीक है चलो तो now Dipanjan chalo let's move to another project. So this is also the similar data set that we use and this was related to semantic similarity. If you guys remember, this was the project wherein we say that said that it's a search model creation and you were given a string, then on the basis of that you were supposed to identify the similar reviews. So this is that particular project. And the second one of NLP project, deep learning. So Dipanjan, let's
Mhm.
talk about this now.
Sure. So basically, this project is mostly to create a search module, okay, or a search bar, where basically,
Dipanjan,
hmm,
I wanted to ask you something. I'm sorry to interrupt in between. I was
sure,
also doing one also this this comparison of two sentences actually basically. So
mhm,
I tried to do this project as well, and I tried to understand that where there is a rating of greater than 0.75, I will be telling them that they are opposite, and if it is no, if it is greater than 0.75, then they are same, and if they are
okay,
less than 0.75, then they are different.
hmm,
I have made coding also for this actually, and
mhm,
if you want I can share you the coding as well, like this I'll just let you know about this. Just give me a
great,
minute.
great.
I'll
So you have done it, right, Aditya?
Yes, I have done that. Just give me a minute. I'll just tell you.
No, it
Sure.
should be okay, Aditya. Dipanjan, it
This
should be okay.
cosine similarity, you were talking about the cosine similarity as well, right? There is an
Mhm.
angle between the vectors, correct? That
Correct.
according to
Hmm.
that will
Cos of
determine that
angle
whether
between. Hmm.
uh, we will be determining that how much the vectors are closer to each other.
Correct. Yes. Yeah, that's a good
So,
thing. Okay, so see, once you identify which one is closer to each other and some
hmm,
number associated with it, right? So cosine number
hmm,
will be in the range of -1 to 1. So any number
hmm,
there you can just multiply with 100, mod of that multiplied by 100. Okay, of course, not mod because minus will be completely opposite. So positive, only consider the positives and multiply with 100, you will get the cutoff there, right? So anything above 75 is you want to classify it as the correct one and only display the ones with 75 plus, you can do that. Okay, that is completely up to you. So you got a
and
metric at least, huh? Hmm.
what I did that is there is one matrix. Sorry, there is one. as from sklearn, I have imported cosine similarity, and from sentence transformers, I have imported sentence transformer.
Okay, anything is
Then
fine. Hmm.
then I passed sentences is equal to df review dot to list, so that it
Okay.
can whatever the reviews that are there, it can be stored in sentences as a variable.
Hmm.
Then I created a model that is sentence transformer. Inside that there is distill BERT
Okay.
uh,
O-
based NLI STSB mean tokens.
Okay. What is that? Can you share your
Uh,
this thing
that
later?
I
Hmm.
cannot share because currently I'm on my mobile actually. I
Not an
wanted to
issue.
know
Later.
this.
Hmm.
Yeah. I will show you actually. If you can be connecting with me at any point of time later, also I can show you that actually. If you can,
No, you can
uh,
send the notebook. I'll review it later. Okay. Later you
okay,
can
okay.
just send it to Ramesh and I'll take a look at it.
Uh-huh.
But yeah, I
Okay,
understand
okay.
you can use any model that is either trained before or you're training it from scratch. It doesn't matter. Okay. Moral of the
Sometimes what
story.
happens,
Hmm.
I always think why it is not happening. Instead of that, I should concentrate on what Ramiz has told me, that I should learn each and everything rather than thinking that why it is not running actually. So that is
Yeah.
the
Correct.
thing
Hmm.
I should be more focusing on actually, what Ramiz is telling. Because if it is
Correct.
not even running, if I know certain things, I can do it later also. But if I
Exactly.
don't know a lot of things, then it will be a problem for me actually. So
Hmm.
I am trying to do that. I think that is the BERT model which you told me, na, the BERT model, right?
Hmm.
For comparing the sentences, it is the form of that only. This distill BERT uh,
Yes.
uh,
Yes. It is a
Bates NLI.
it's a different architecture though from BERT. Okay,
Mm.
but the base is BERT. Okay, just print that distill BERT. You'll understand. But it is on top of BERT only. Okay, so just look at it later. But yeah, moral of the story is just that you create embeddings that are either pre-trained or you're first build the model and then get the embeddings. Okay, whatever it be the case, and end of the day you're just going to compare the two vectors. Bus or कुछ भी नहीं है इसमें. Okay, that's all is what
हाँ,
you're doing.
वो वही मैंने किया, पर वो हो नहीं रहा है, वो एक्चुअली आंसर नहीं आ रहा है, उसका आउटपुट ही नहीं आ रहा, बस वो रन करता है और चुप हो जाता है मतलब.
Just check, okay, what you're doing. I don't know.
Because
You can
Aditya, I'm
share me
telling
this
you,
thing.
you are like one of the most sincere candidates I have come across. So
Thank you, Raman.
we have been constantly running this program now, okay? And it's like 3 to 4 batches we did, and one of the sincere candidates. So we had sincere people and all, but you are also one of them. So wherein you are ready to put the effort, you are trying to do the stuff, okay? And now uh, as along with doing this, you put your efforts in the right direction, so that ultimately it should not happen that what happens generally is that when we sincerely do something, and if we observe that probably something is not working out or something is not happening as per the expectation, then ultimately someone may get demotivated. So or someone may say that, okay, why is it not happening? So if that happens, then the next step should be to see where the things are lacking and upscale or upskill on that. So approach, keep this as an approach. So although chalo, now you are executing the project, okay, now you are executing the project, you have a pi file shared, you have the video recording shared. On the basis of that, primarily try to execute the project. Second thing is, if in case you get stuck somewhere, those recordings and IPYNB files are not made in a manner that someone can directly copy and paste the stuff there. They are very well explained, but it's not a cakewalk. So like things are like here and there. That is what it is. So upscale yourself. First, try to execute the project. Second, try to get in the understanding and bring all these things into picture so that you do not get demotivated, and take a project by project ahead. Take a project by project ahead. If you try to complete the one project, then try to complete the another project. Give 3 to 4 days for completing one project, then after that a couple of more days for completing another project. So systematic way se bado, and that would be a better approach for doing it. And when it comes to internship, these are self accomplished projects, so these are not having those timelines. that you can try to do it, complete it in 2.5 months or 3 months. In fact, there is no timeline for this. But when it comes to internship project, the projects which we discussed or we are going to talk about in second half of today, those things are supposed to be taken on priority. And meanwhile, break your day into two. ये भी करते रहो, वो भी करते रहो, and if you feel that now training is required so that basic concepts and related stuff comes more handy with you, then take that as so also break your day into three and keep working towards all those things.
Okay,
ठीक
Ramesh.
है?
Yeah.
चलो दीपांजन, अभी now let's move on. चलो दीपांजन, we were in this semantic
Hmm.
similarity deep learning project, IMDP dataset, and we're talking about why did we select this project. It's a search model creation, that is what you just said, and now we were going to talk in further about that. Let's continue with that.
I'll maybe give you directly all the interview questions here. Okay. So there
Sure.
are only two things here. Okay. एक तो तुम्हारा embeddings, another thing is your metrics. That's all. Coming to embeddings, what embedding did you use? You can talk about 100 different embeddings that we just discussed before some time, right? BERT is one of them. TF-IDF is another one. Then you have universal sentence encoder. These three are what we used here. Okay, there is a count vectorizer. You have word2vec. You have your CBOW, right? A bag of words. So multiple things are already available. Check which one works for you. Okay, I mean, of course, like read as much as possible. In the interview, you can just say, I use this. Okay, but इतने सारे already हैं ना embeddings that you don't have to say I know all the embeddings. Okay, you just say I use this, I use this. They will ask questions on top of that only. Okay, so any embedding of your choice, just know the entirety of the embeddings. Okay, when you say BERT embeddings, okay, so BERT. So sometimes I ask these questions to a few people. Okay, even experience with around 6-7 years of experience people. When I ask simple question, ki, how does the BERT output look like? Simple as that. Okay, people who have not worked with BERT, na, they will be struggling like anything here. They'll be like, okay, we do the chunking, we do this, that. No, no, I don't want to know about all those things. I just want to know what is the output of BERT. Okay, so people who have worked with BERT, they will know. Okay, there are two kinds of outputs here. One is the pooled output, another is the sequence based output. So you need to know this now. Okay, people will say this also. Okay, like there are two kinds of outputs, sequence based output and pooled output. Then when you talk about the dimensions, right? Like how would, can you give me the dimension of sequence based output? Is it 1 comma 3 comma 4, 10 comma 7 comma 8? How does it look like? Okay, in terms of dimensions, they are confused. Okay, so if you have worked with BERT really, na, you will be able to see each and everything on the output. You will learn from there. Okay, just do it uh, yourself. Okay, of course, like for this particular thing, you're using pooled output, but know what is the output dimensions of BERT. Okay, that I would definitely recommend. And so this is one, your embeddings, and second part is your similarity metrics, right? Now, similarity metrics में भी बहुत सारा similarity metrics exist. Okay, so you have cosine similarity, Euclidean distance. These are the two widely used. Then there is dot product. Then you have Manhattan distance. There are n number of distances that you can use, right? Projection distance. Then top projection, bottom projection, any kind of projections. Then your angles between them. So multiple distances you can think about between two vectors that you can uh, operations between two vectors that you can think about. Okay, comes in these distance category basically. Okay, simple summation of your perimeters is also one of the distance and things like that, right? So many distances are there, but three most important things are cosine similarity, dot product, and Euclidean distance. Okay, so these three things be very pakka with, and also know that how are each one of them calculated. Okay, so okay, another question that I sometimes ask is, let's say that you used a embedding that is standardized to 1. Okay, by standardized to 1 I mean, let's say that you used a embedding jiska magnitude will always be 1. Okay, so you have uh, okay, I'll name the embedding directly. Okay, there are embeddings that come from OpenAI. okay, like your ADA002, ADA003 embeddings, okay, that Microsoft provides, but their magnitudes are always one. If you just see कोई भी sentence लो, get the embedding for that sentence, find the magnitude of that embedding of that vector, you will always get close to one. Okay, 1 point something, 1.1, something like that you will get close to one. In that particular case, do you think cosine similarity and dot product is going to be different? Okay, it's actually same, but people get confused. Okay, like if magnitude is one, you will have cosine similarity and dot product as same. Okay, so you have to think accordingly. Okay, we'll just say that magnitude is one. How do you think cosine similarity and dot product will look like? Is it going to change if you use a different instead of cosine similarity? If I use dot product, is it going to change if my vector embeddings are ADA002 embeddings? They'll get confused. Don't get confused in these cases. Okay. So if you know these formula and things like that, it will be pretty easy. But on the spot, when people ask questions, you have to apply those things, right? So you know formulas, you know everything, but then when they ask you questions, magnitude one, how is it going to link these two things? If you know the formula, still you will not apply that formula to understand what is the difference, what is the relationship between cosine and dot product and things like that, right? So know these things, and now very important for your next topic as well, which is your vector databases and vector stores, right? So once you create the embeddings, where did you store these embeddings, right? Did you store it in a database? Did you store it in a pickle file? Did you keep it in Excel, or it was just runtime? Okay, कि मैंने बनाया, जैसे ही notebook बंद कर दिया, सब garbage में चला गया, right? Again, you have to run the entire notebook. Then only you will generate the embeddings and things like that. Otherwise, you don't have the embedding stored anywhere. It's just gone, right? So they will ask you, like, if you want to build a something, if you want to build something scalable, where will you store these kind of embeddings? Do you want to keep these in runtime, or do you have better ways to store these embeddings, right? So you have vector stores, vector databases for storing these embeddings. Of course, you can do it in databases as well, but they are not meant to
Dipanjan, I have
basically
one
do these things.
question.
Yeah.
I have one question. When we are doing embeddings, exactly what we are doing actually, sentence embeddings.
See, what we are trying to do is just get some numerical representation out of sentences. That's all. Now, the numerical representations can be very intelligent, or it can have very less number of intelligence. I mean, very less intelligence based on just some words that are occurring. Okay, so let's say that, how do I put it? Like, so there are two kinds of embeddings. Okay, one is very contextual embedding that can understand the entire context of what is there in the sentence. Okay, or there are few embeddings that are of very weak quality. Okay, like it cannot understand the context, it cannot understand the sequence, it can just understand some of the information, like your TF-IDF, right? It can simply capture how many times this particular token is coming, or कुछ भी नहीं capture कर रहा ना. It's just able to capture, see, let's say that I'm a good boy is coming in 3-4 places, good boy is coming in 4-5 places, it will have more uh, frequencies, right? Accordingly, the values will be like if you divide by the number of frequencies, divide by the frequency, that day those values will be lower, right? So that way, your embeddings can understand the frequencies of words only in TF-IDF, right? But if you have a different model that was trained to generate embeddings in such a way that they are intelligent embeddings, then they are trained in such a way that the embeddings will be close to each other. Okay, that is how the model is trained. Okay, like after you do the after you fit the model, get the embeddings and do a clustering, you will see that the vectors that are close to each other actually mean the same thing or somewhere nearby in context, right? That is how models are built. So moral of the story is, uh, you're just converting the sentences to some number representations. Now number representations can be very intelligent, or it can be moderately intelligent. Okay, nowadays you have very intelligent embeddings, but back like 8 or 9 years back, you will probably have nothing else there. You will have continuous bag of words, TF-IDF, which are mostly based on your frequencies. right? So just to capture as much information as possible from the sentences is what you want,
ठीक है चलो.
right?
So
Aditya, any more questions? Are you confused yet, or does it answer your question?
So it means like you are telling that sentences should be converted into numbers if we are using the embeddings, right? And
Correct.
am
You
I
want to
correct?
capture all the information from the sentence in some representation, right? Yeah.
And when we are doing it through TF-IDF, it is converting into vector form, right? So the sentences are there. Those sentences has some words, and it determines the frequency of the words which are repeating in the sentences.
Correct. Yes. So TF-IDF, see, TF-IDF cannot see what those words are. Okay. TF-IDF cannot see that it is coming multiple times or not. Okay. It will just say that there is one token. That token ID is 1562. That is coming 11 times, right? उसको उसको नहीं पता कि what word it is, right? Everything is token. So TF-IDF is only going to give you frequencies of each and every word in some representations. That's all. It's not going to capture context at all, right? So every embedding has some plus minus, right? So nowadays the race is on to get good models that can generate better embeddings, right? So text ADA 002, 003 LARs. So OpenAI is providing very nice models that can basically generate superior embeddings that can understand context, right?
नहीं मैं ये पूछ रहा था कि it is coming how many times the words in the sentences, it is determined by TF-IDF. And similarly, if we want to convert those sentences into numbers, then we will be using embeddings, right, to convert those sentences into numbers.
No, 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 no. Wait. I think you're confused about TF-IDF. Okay, so okay, just check what is the formula of TF-IDF. Okay, so let's say that in you have multiple records. Okay, multiple examples. So in first example, you have the word am, you have good. Okay, and that am and good is occurring many number of times. Okay, so it has a huge number of frequencies. So if you look into the formula, frequency I think comes in the denominator somewhere, right? So that way your uh, the value of TF-IDF ka value will reduce for am and good. Okay, and if you have less number of uh, am and good, let's say another word, let's say let me take bad and okay. Okay, bad and okay are two words. So let's say that bad and okay is occurring a lot of time in one sentence, but very less number of times in many other sentences. Okay, those values will be very high. So us particular word ka, okay, corresponding to that word, you will have a higher value there in your embedding. So isse na you can simply capture the frequencies, nothing else, right? You got the point, right? So okay, now you're saying that okay. So what I am doing? Okay, I am a good boy. Uh, for I have a token ID 1. Am I have a token ID 2. Okay, so these are just your features. So for each and every feature, you will have some value associated with it. Correct? So if my vocabulary size is 40,000, so for 40,000 words, you will have some or the other value there. Correct?
Okay,
It can
so
be
after
000
having
as well.
after so TF-ID will give those values, correct?
Correct, yes.
And sentence embeddings will do what exactly?
It is the same thing. Okay, so okay, see what you're trying to do is get embeddings out of sentences. TF-IDF is one way to generate sentence embedding, right? TF-IDF also is giving you sentence embeddings. Now there are other ways also to do sentence embedding. Okay, so TF-IDF is one. You can use BERT embeddings. You can use word to vec. You can use these are all sentence embeddings only. Okay, so don't get confused
Okay.
between these two things. It's just getting the numerical representations. That's all.
so Dipanjan,
Okay.
let's move on. Aditya, एक ट्रेनिंग genuinely pick up a
Hmm.
training which is into data science
Uh,
in parallel करो
hmm.
because like एक बार training लेगे तो your core concept should be all in place. So that would be helpful for you if you try to switch from data science to data analyst. And as you are working already, you don't have that pressure on you. like there is no pressure like not working or something like that. You have some base, but take some quick training and उस पे build करना शुरू करो. ठीक है. So Dipanjan, any so now we completed all the questions that can be asked when it comes to semantic similarity. So guys, again, important thing that I want to suggest here is that add only those things in your project which you will be in a position to talk about. So first do, first execute, and then update your resume, update your project. Nothing should be there in your resume that you have not done on your own. If in case that happens, then you will not be in a position to answer related to the questions in an interview. So you have to first ensure that you do these things and then upload it in the resume. Don't do it just for the sake of uploading it. You should be thoroughly aware of what you're talking about.